All right, our Vsepr shape we're going to do right now is dihydrogen selenide. So now you have to know how to convert this guy to the formula so we know what we're talking about. Dihydrogen, di means two, so two hydrogens. Selenide, selenide is Se. Who is my central atom? That would be selenium, okay, because he has two gaps as opposed to hydrogen who only has one gap. So selenium goes in the center, hydrogen goes on the outside. Okay. Hydrogen has one valence electron, selenium has 6 valence electrons. Okay, so I check it, 1, 1, 1, 2, 3, 4, 5, 6. Okay, I have the correct number of valence electrons. Now I have to form octets. So I'm going to start by giving everybody single bonds. Okay. Now hydrogen can only do a single bond, so actually he's done. 2 means hydrogen is now full. Hydrogen, 2, he's now full. Selenium, let's check him. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So he is good, and that makes sense because selenium only has 2 gaps, so the maximum he can have is 2 bonds, and he has 2 bonds. So this is our structure. Let me just rewrite it with the bars. And remember, all those unbonded electrons, those are the ones that are not paired up with somebody else. Go sit on the top, kind of like a hat. And that's important once we get to Vsepr structure, which is where we're at now. So it's good you've been practicing putting the lone pairs up on the top. So if it's on the central atom and it's extra electrons, you put them together, and they're called lone pairs. So this guy has 1 set of lone pairs, 2 sets of lone pairs. Okay, so I'm just going to write that down because I need that for the Vsepr shape. 2 lone pairs. Okay. The other thing I need for my Vsepr shape is atoms off the central atom. That just means ignore the central atom and count up who's on the outside. I have 2 on the outside. 2 off central. So my code is a 2, 2. So when I look at my chart, bonding domains is also number of atoms off the central atom, so I'm looking for a 2, and number of lone pairs. So 2 electrons off the central atom, 2 lone pairs, give me a shape that looks like this. That shape is called bent at 105. So I write bent 105 degrees, and then I have to decide if it's symmetric or not. Okay, this guy, when I look at him here, he actually looks symmetric. But when I look down here, I see I have lone pairs. So he is not symmetric, which means he is polar.